Good afternoon. Welcome to another of our series of additional mathematics classes. I am Duane Mackenzie, your teacher for today. Chevanese, good afternoon.
Good afternoon, sir.
How was your last mathematics class?
It was okay. We looked at the remainder theorem.
Okay, so you looked at the remainder theorem. So, what can you tell me about the remainder theorem? Did you enjoy it?
Well, it was fairly easy. If we are asked to divide a polynomial by, let's say, x take away 2, all we have to do is substitute the variable for 2 in the polynomial, and the answer would be the remainder.
Okay, so you are saying that it was easy because all you had to do was substitute values. That is very, very interesting. So what you just said to me is that all you need to do is to substitute values. And I know that students like when all they have to do is to substitute values. But I am sure that you only said that to make it look extremely easy, because I know that your teacher would have given you some problems that it requires more than just substituting.
Yes, sir.
So Chevanese, tell me something. What if you were asked to divide a polynomial by, let's say, 2x minus 3? How would you approach that? Would you just plug in 3 in the polynomial if you were asked to find the remainder, if you divide it by that?
We're told to think about it as solving for x. So in this case, x would be 3 over 2. So you would just substitute 3 over 2 for x in the polynomial, and the answer would be the remainder.
Very good. I see where you have been learning a lot, and that's very impressive. My viewers, were you thinking the same thing? Did you have that question in mind? Were you ever given a question looking like that? These are things to ponder. Well, Chevanese and viewers, what we're going to look at now is something quite similar. So our focus for today is still polynomials. We are still at polynomials, but we'll be looking at what we call now the factor theorem. Now, at the end of this class, students should be able to apply the factor theorem to factors of various polynomials, solve for the unknowns of various polynomials using the factor theorem. Now, the factor theorem, what are we talking about? So if we have an n degree polynomial and we want to find out whether something is a factor or not, this is extremely simple. So we are going back to what Chevanese stated before. So let's look at the first polynomial here. We are looking at x squared minus 3x minus 4. When we factorize this, we'll get x minus 4 times x plus 1. Here we are saying that x minus 4 is a factor. Therefore, f of 4 is equal to 0. Now, that is
Question,
straightforward.
sir.
Oh, a question. Yes, Chevanese, ask your question.
Why would f of 4 be equal to 0?
Okay, a very good question. Now, remember I stated before, so if we look at this polynomial, if we are supposed to put a 4, so let us put 4 right here. This would be 4 minus 4. We'll get a 0 here. But let's go even further. If we put the 4 right here, which is basically saying the same thing, then this becomes 0. And 0 times what we have over here would also give us 0. So that is why we can categorically state that this f of 4 would be equal to 0. Now we look at this now. Look at the x plus 1. This is also a factor. It is right here. Now, if we put in negative 1 here, this becomes 0. And then also, this will become 0 because when you multiply by 0, we would get 0 for answer. Anything multiplied by 0 gives us 0. All right, Chevanese, is that clear?
Yes, sir.
Viewers, I hope that that was clear to you as well. And I know that some of you had that question in mind. Now, if we go down to this one here, where we have f of x is equal to 2x cubed minus x squared minus 10x plus 8, when we factor it, we'll get this here. What we have is x minus 2, open and close brackets, 2x squared plus 3x minus 4. So we have right here now a binomial and a trinomial. Now, if x minus 2 is a factor, which we see here because we factorized it, then f of 2 would be equal to 0 as well. Because if we put a 2 here, 2 minus 2 is 0, so this becomes 0. What are we trying to say here? Well, in general, if f of x is equal to x minus p times something else, then x minus p is a factor. Therefore, f of p is equal to 0. Or if f of x is equal to x plus q times something else, then x plus q is a factor. Therefore, f of negative q is equal to 0. Now, like what I asked Chevanese before, my viewers, you would have realized that I asked her one time a question where she was asked to use 2x minus 3 as a factor. This can also be said here. So it's not shown here, but if there is a constant that is not 1 before the x variable, then all we need to do, think about it like we're actually solving for x. All right? So in summary, if f of x is a polynomial and f of p is equal to 0, then x minus p is a factor of f of x. Or if f of x is a polynomial and f of negative q is equal to 0, then x plus q is a factor of f of x. So this is basically what the factor theorem states. It is not difficult. It is very simple, even simpler than the remainder theory. Okay, now Chevanese and viewers, let us now look at an example. Use the factor theorem to determine whether x plus 3 is a factor of x squared plus 2x minus 3 or not. Given p of x is equal to x squared plus 2x minus 3. Our divisor is x plus 3. Using the factor theorem, if x plus 3 is a factor, then p of negative 3 should be equal to 0. Let us look now. So p of negative 3, so we are substituting here. So it's negative 3 squared, that should give us 9. 2 times negative 3, that should give us negative 6. Okay, and we have a minus 3 there. What do we do now? Basic addition. So that gives us 9 minus 9, that is 0. So indeed, this is telling us that x plus 3 is a factor of x squared plus 2x minus 3. I am assuming that this was very easy for you, right, Chevanese?
Yes, sir.
You understood all the steps clearly?
Yes, sir. I think so.
Okay, and viewers, I hope that you look through all the steps and you're having a good understanding, or you are grasping this as best as possible. It is not difficult. As you can see, it is basic algebra. Now, Chevanese and viewers, I have something for all of you. I have a nice little example for you to try. Are you up to it, Chevanese?
Yes, sir.
All right. Now, you're going to use the factor theorem to determine whether g of x is a factor of p of x if p of x is equal to 2x cubed plus 6x squared plus x plus 3 and g of x is equal to x plus 3. The floor is
Okay,
yours,
sir.
Chevanese.
P of x is equal to x cubed plus 6x squared plus x plus 3. And g of x would be equal to x plus 3. P of -3 would be equal to 0. And this is by using the factor theorem. So now we have
Lovely.
P bracket -3 equal 2 bracket -3 cubed plus 6 bracket -3 squared, take away 3 plus 3. And that would be equal to -54 plus 54 minus 3 plus 3, which will give us 0. So it is indeed a factor of 2x plus 6x, 2x cubed plus 6x squared plus x plus 3, that P of -3 equals 0.
Well, well done. That was very impressive. And I hope that my viewers, you also arrived at this answer. All right, that was extremely impressive. And I am going to tell you that without even showing you my solution, I know that that answer is indeed correct because I saw 0 there. So let me just go through the formality, Chevanese and viewers, because that was well executed. So let us look at it. Looking good. And yes, extremely impressive. And I must say that you guys are doing well. I see where you are practicing, and things like these are becoming a non-issue now, non-factor, pun intended. Because if you look at this, the directed numbers from time to time gives students a lot of trouble. And normally for questions like these, they would make some silly mistakes with their signs. This was not the case with Chevanese nor you guys. Well done. So students in TV land and Chevanese, you have been doing well thus far. I have another example for you guys. But what I want you to look at now is not just the example, but I want you to tell me on seeing something like this. I know, yes, it is worked through for most of it, for the most part. However, Chevanese, and I want my viewers to think about this too. What jumps out at you when you see this particular example?
Two things jump out at me. Firstly,
Ooh,
it looks somewhat difficult.
I knew that she would say that. Continue. I knew you would say that.
Because the coefficient of x squared is missing. I also realized there is a linear equation at the bottom of the slide. Should I take it that when one coefficient is missing, I should solve a linear equation?
That is good thinking. Okay, that is very nice. And that's a good way to look at it, you know. So one coefficient is missing and you're seeing a linear equation. So you're asking if you should take it that you should solve a linear equation. All right, yes, you can. That is a good way to start, a good way to think about it. And when we move to further examples, this might strengthen your conviction in terms of what you just said a while ago. All right. So yes, Chevanese, questions like these, and also to students in TV land, viewers elsewhere, questions like these normally pose a problem for many students. Reason being, they are now required to do some form of algebraic manipulation to arrive at a particular answer. But this does not mean it is any different. Because if you look at this, we know that x minus 2 is a factor of the polynomial. And by the factor theorem, we also know that p of 2 will be equal to 0. So what we do here is our usual substitution. When we substitute p of 2, you would realize that we'll end up with 8 minus 4m plus 20 minus 20. And this linear equation, as stated by Chevanese, is basically the solution. All we need to do now is to simply solve for m. That is what the question is actually asking. So it is not difficult. We just apply what we know and we arrive at a beautiful solution. So do not look at problems like these as being difficult. Just apply what you know and you will eventually reach at some point where it looks familiar. Looking at this, it's simple. M is equal to 2. So there was nothing difficult about this. Right, Chevanese? Was it difficult?
Yeah. Not really, sir.
All right. So do not look at problems like these and think that they are difficult. They are just set differently to test for some additional knowledge. It just calls for more mental dexterity and also algebraic manipulation. So you know, following an example, and people, viewers in TV land, you know, following an example, that you will also be asked to take on something quite similar. So here is your task for me now. You're going to try this one.
Yes, sir. P of x is equal to 2x cubed plus nx squared
Some more volume for me, Chevanese.
n plus x plus 3, where the divisor is equal to x plus 3, and p of negative 3 will be equal to 0 for the factor theorem, and p of negative 3 would be equal to 2 bracket negative 3 cubed plus n bracket negative 3 squared plus negative 3 plus 3. And that would be equal to negative 54 plus 9n, and 9n would be equal to 54, where n equals 6.
Well done, Chevanese. And I can tell you from now that your answer is indeed correct. Viewers in TV land, on the internet, if you have gotten this for your answer, well done. If you did not, better luck next time. You must still try and try and try. In the end, you will succeed. So good job, Chevanese, and keep this up. I might just have something special for you at the end of this class. So just as a mere formality, we'll now look at the answer that Chevanese just got a while ago. So well done again, Chevanese, and all of those who got it correct. in TV land or on the internet, well done. I am proud of you guys. Chevanese, you have been doing well thus far, and viewers, I know that you have been doing well as well. Now, I have another example for you guys. Now, this example might be a bit tricky, but once you look at it and once you try to understand what you are seeing, you would realize that it is no different from the ones that you saw before. So look at this question. If 3x to the fourth power plus px cubed plus qx squared plus 4 is divisible by x squared plus x minus 2, evaluate the values of p and q. Now, when you look at something like this, a few things will jump out at you immediately. The first thing that I know will jump out at you is the fact that you are seeing not one, but two coefficients of the x's, the cube and the square, that are unknowns. Now, in a previous example, we saw one unknown. Now, this might get you scared. Like I said before, nothing is wrong with a question like this. It just looks a bit different and a bit more complex. But please bear with me as I navigate you through this simple but eloquent problem. The second thing that might jump out at you is the divisor. Normally, you are used to dividing by a binomial. Now we have a trinomial. But like I said before, and I will always say, do not get scared when you see something looking like this. All we need to do is to break it down into simpler parts. So the solution. So let p of x is equal to 3x to the 4th plus px cubed plus qx squared plus 4. The first thing that we can do, or the first thing that we should do, rather, is to take this trinomial and factor it. Now, this is a simple factorization. So this will factor to x plus 2 times x minus 1. Once we put it like this, it becomes much easier already. Right now, you should be jumping with joy because you are now seeing something that you are very familiar with. So let us continue. So we know now that p of x is divisible by x plus 2 and x minus 1. We saw that in the previous step. Now, by the factor theorem, p of negative 2 is equal to 0 and also p of 1. Nothing is new here. This is what we have done before on numerous occasions. So what do we do now? We evaluate. Now, one thing I must say here before we move on. Now, viewers, if you remembered, Chevanese stated that when there was one variable before the x exponent, she was thinking of solving a linear equation. Now, if we look at this, we have two variables before the x exponents. We have p and we have q. This should be a clue. Now, we can now look at this as, oh, we have two variables. So when we have two variables are unknown in equations, we normally think about, to solve for them, we need two equations to solve simultaneously. Nothing has changed here. So we are thinking now to solve a simultaneous equation. So if we look at this, when we look at p of negative 2, when we do the calculation, it yields 48 minus 8p minus 4q plus 4. So that becomes 52 when we add that 48 and that 4. And the other two variables now will remain the same. That's the minus 8p and the minus 4q. We cannot add them because they are not like terms. So P of 1 will be equal to 7 plus P minus Q. And that will be equal to 0 based off the factor theorem. And that now is equation 2. What should we do next? Simple. We have two equations we can now solve for P and Q. First thing that we did was to actually write Q in terms of P. This makes it easier to solve for P. Now, after doing some algebraic manipulation, we arrived at the fact that P is equal to 2. If P is equal to 2, we are now left with a basic equation to solve for Q. What do we do? That's it. We substitute P equal to in the equation Q is equal to P plus 7. Thus, Q is equal to 2 plus 7, Q will be equal to 9. Now, you cannot tell me that this was not a very simple solution. Initially, it looked very difficult, but after a while, you realize that we broke it down into bite sizes where we can take it one step at a time. So when we see problems like these, do not panic. Just take your time, analyze it, and break it down into simpler parts that is very manageable. Use what you know and build on it. Now, since you have seen how we navigated this problem, I have one for you to try. Now, if x cubed plus p of x squared plus q of x plus 6 is divisible by x squared plus 3x plus 2, evaluate the values of the constants p and q.
To be honest, I didn't think it would be this easy, but after seeing the example, I have a lot more confidence now.
Well done, Chevanese. Please take it away.
So we have p of x, which is equal to x cubed plus px squared plus qx plus 6, and x squared plus 3x plus 2 will be equal to x plus 1 close bracket open bracket x plus 2 by factorization. And now we have p of negative 1 and p of negative 2, which is equal to 0 by the factor theorem. And so now we're going to work equation 1, where we have p of negative 1 equals bracket negative 1 cubed plus p bracket negative 1 squared plus q bracket negative 1 plus 6, and 0 equals negative 1 plus p take away q plus 6, p take away q equals negative 5, and that would be equation number 1. So for equation number 2, we're going to have p of negative 2, which is equal to bracket negative 2 cubed plus p bracket negative 2 squared plus q bracket negative 2 plus 6, which is equal to negative 8 plus 4p take away 2q plus 6. and 0 equals -2 plus 4p, take away 2q, and 4p take away 2q would be equal to 2, and that would be for equation number 2. And now we're going to solve the equations 1 and 2 for p and q. So we're going to have 4p take away q equals 2, and p take away q equals -5. So for equation number 1, where we're finding q, we're going to have 4 bracket -5 plus q, take away 2q equals 2, and -20 plus 4q minus 2q is going to equal 2. 2q would be equal to 22, and q would then be equal to 11. So now q would now be equal to 11. Then we're going to substitute 11 for q in equation number 1 to get p. So we would have p minus bracket 11 equals -5, where p is equal to -5 plus 11. P is now equal to 6. So P equals 6 and Q equals 11.
Well done, Chevanese. And I hope that my viewers would have gotten something similar. And I like how you explained your steps clearly and precisely. Very good job. Well, you know, as usual, once you work something, I have some level of confidence in your work. Now, for just the mere formality, I will just go through the solution that we have to see how you and our viewers stack up. And remember, like I said before, and will always say, if you did this and you did not get the correct answer, better luck next time. Do not give up. You will get it eventually. Just try and try and try. So let us see. So let us see. Very good. All right. So we are just confirming what Chevanese did. What she had was perfect. All right. So we have there the p of the -1 for equation 1, p of -2 for equation 2, and we got our equations. Now all we need to do is just to solve these simple equations. So indeed, p is equal to 6 and q is equal to 11. Very good job. Indeed, p is equal to 6 and q is equal to 11. Very good job all. Now, we're going to stop here for this lesson. But like I said before, you must, if you got this incorrect, try and try. Eventually, you will get it. Now you can actually go find a textbook or go on the internet, look for similar problems to solve. So when we come for the next class, you can feel more confident that you have actually mastered the factor theorem. So until next class, take care.